Assalamualaikum and a very good day to all. My name is Ummi and I would like to present my final year research topic, which is the development and characterization of sewage Sludge-Cassava based activated carbon. Here are some of my table of contents. So first is a little summarization from my final year project 1, where activated carbon is widely used as catalyst support and adsorbent for the removal of pollutant odor from liquid to gases and for purification or recovery of chemicals. A wide range of carbonation materials such as agricultural waste or industrial waste, coconut shell, coal and wood can be used as activated carbon precursor. In industrial practice, coal and coconut shell are two major sources for the production of activated carbon. Activated carbon is also an adsorbent produced from carbonaceous raw material, of which much of the active non-carbon components and a fraction of the initial carbon content have been eliminated through thermal or chemical, resulting in a structure with a large surface area. The low-cost materials that are rich in high carbon concentration and low in organic content have been used as raw materials for development of activated carbon. In recent years, several researchers have used waste as precursor to activated carbon processing for 4 key reasons, which are sustainable, affordable, readily available, and environmentally safe. In this study, I have been focused more on the sewage sludge and cassava peel. Sludge is a byproduct during the water treatment process. It's hard to treat because of its different constituent elements, while sewage refers to a liquid waste from non-industrial human operations and includes waterborne bacteria, which can cause severe human illness. In addition, sewage sludge is an organic substance rich in nutrients, roughly 60% of which come from sewage and up to 40% of which come from microorganisms or biomass that emerge during the process of treatment. Next, cassava peel, where it contains 66% hollow cellulose, 37.9% cellulose, 23.9% hemicellulose, and 7.5% lignin each. According to the Central Bureau of Statistics from 2004-2008, the production of cassava continues to increase annually, which means that the production of cassava peel is also increasing. Usually, cassava peels have a higher content of cyanogenic glucosides than the pulp. As for the problem statement, increasing the degree of socio-economic growth as well as investment in water and sewage, including the construction and the modernization of sewage treatment plants, are the key factors influencing the increase in the production of water and sewage in the municipal sector, thereby increasing the amount of municipal sewage sludge produced. In exchange, rising costs for the provision of water and the collection of waste are significant factors restricting this trend. Nevertheless, the absorption capacity of waste-based activated carbon to pollutants are typically limited due to the comparatively high ash and inorganics in the urban sludge. In order to control the low carbon content in waste-based activated carbon, any carbon source material can be added to exhibit abundant pore structures and strong absorption performance. So, I decided to use another non-conventional material, which is sludge. Also, this study is used the cassava peel to develop a new type of carbon source material in order to increase the efficiency rate when comparing with the conventional precursor. Next, here are my objectives toward the research topic. First, to review a sewage sludge-based activated carbon with the carbon source material of cassava peel, to study the characteristic of an activated carbon based on the surface area and pore size, surface functional groups, surface morphology, and the percentage of carbon, hydrogen, nitrogen, and sulfur that present in the samples. And also to compare the sewage sludge-based activated carbon, the sewage sludge-based activated carbon with cassava peel as the carbon source, and the commercial activated carbon. Then, my research scope. First, analysis on the current conventional precursor of an activated carbon, study on a waste-based activated carbon by adding some agricultural residues of the carbon source, and also analysis on the characterization of a waste-based activated carbon. Last but not least, the methodology. This is the experimental framework that I extract from my research. So first, for preparation, we collect the mixed liquid of sludge from setting tank. Then the sample is drying for 24 hours in an oven at 110 degrees Celsius, then crushing it manually and sieve. Then for alkaline treatment, the cassava peel is sliced into smaller pieces, milling and then wash it with purified water, then mix with 2% of potassium hydroxide solution in a microwave of 90 degrees Celsius for about 120 minutes to eliminate the moisture content and increase its alkalinity. By using potassium hydroxide, chemical activation of the sludge is assumed to be achieved. The dried sewage sludge is then combined with dissolution and left for 24 hours. Next, pyrolysis is carried out under reduced air condition, where the pyrolysis temperature is selected to be approximately 550 degrees Celsius to 600 degrees Celsius. The sample is then needed to be removed from the furnace following completion of the pyrolysis and being pulverized. Then, using 500 ml of 0.2 mol potassium hydroxide to eliminate excess circulating agent and residual inorganic matter. Pyrolysis is accompanied by rinsing. This is to extract the remaining potassium hydroxide with 500 ml of purified water. After that, the chemical active substance is placed in 100 degrees Celsius of hot air oven and stored for further characterization. Then, analysis on the characterization of the activated carbon. For BET analysis, all samples of 200 mg at 80 degrees Celsius with a surface area and pore size analyzer. The porous properties of the prepared activated carbon is calculated by a process of nitrogen absorption. Then, FTIR. All samples of 200 mg is then placed in FTIR spectrometer to figure out its functional group based on the frequency range. Next, SEM, where all samples of 200 mg is placed in SEM at an accelerating voltage of 15 kV. And lastly, CHNS, where all samples of 200 mg will go through a temperature of 1800 degrees Celsius. Next is the results and discussion. So first, based on Arsenal 2011, the result on activated carbon surface area and pore size using BET equipment shown that the samples prepared by chemical activation indicate a wide variety of surface area, varies from 50 meters squared per gram to 695 meters squared per gram. This graph shows the result for pore volume and BET surface area, where clearly shows that as the BET surface area increases or decreases, the overall pore volume for all samples with activation also the same. Next, based on Mopong and others 2015 research, the result on FTIR analysis of activated carbon prepared with potassium hydroxide to sewage sludge ratios of 0.5 to 1.5 based on cassava peel and activated at 500 to 700 degrees Celsius. It can be shown that the whole spectrum is identical. At around 20,200 per centimeter, there is a wide line, a very weak peak at 1,600 and a strong peak at 1,400 per centimeter. Next, also based on Mopong and others 2015 research, the result on SEM analysis which can be seen from the micrograph that there are cracks on the outer surface of the activated carbon particles and several crystals in large holes of different sizes. Lastly, based on Al-Mahbashi and others 2020 research, elemental CHNS analyzer results showed the percentage of nitrogen, carbon, hydrogen, and sulfur in sewage sludge and activated carbon. Sewage sludge carbon content is 30.82%, making it a good raw material for the production of activated carbon. The high nitrogen content in sewage sludge, which is 12.09%, is attributed to protein fraction of microorganisms developed during the treatment process of wastewater. The reduction in carbon content of activated carbon could be attributed to the releasing of volatile matter during heating process. Lastly, sewage treatment produces a lot activated sludge. If the sludge is prepared into sludge-based activated carbon, it can reduce environmental pollution and bring considerable economic value. Furthermore, cassava peels have been discovered to excellent absorber material for wastewater treatment, particularly in the removal of heavy metals and other organisms that tend to change the water's original characteristic. Due to their larger surface area and pore size, including their functional groups of surfaces, sewage sludge cassava peel-based activated carbon can achieve high uptakes of dyes and metal ions, while the good absorption efficiency of the activated carbon is derived from a high degree of mesoporosity. Therefore, this research topic of development and characterization of sewage sludge cassava peel-based activated carbon can be concluded that it has a potential value to be developed and be practiced by most of the industries. And then here are some of my references. And that's all from me. Thank you.